Right, question 5. Figure 8 shows the graph of the current through a component Y for different values of potential difference. Draw the circuit symbol for the component. Well, which component is this? And there are 3 graphs you must recognize. This one is a diode. What do the other graphs look like? One looks like this, a nice line straight through the origin, perfectly straight. That's a fixed resistor, an ohmic conductor. Maybe you've come across that term. And the other is a bulb, and your graph is going to look something like that, where it tails off at the top and it tails off at the bottom, and that's a filament bulb, specifically a filament bulb. Filament bulb. Oh, filament bulb. The filament being that thin piece of wire that you can see inside it. So if I just sketch that bit there, that's your filament. Glows hot. Right, so anyway, this component we established was a diode, and we need to draw the circuit symbol for that. The circuit symbol for a diode looks like this, a triangle, like a play or pause button, inside a circle with a circle going around it. If you wanted to find all of the circuit symbols, you could search on Google, say GCSE AQA circuit symbols, and one of the first images will give you all of them. Alternatively, go to your specification, search AQA physics specification, and that gives you the list of basically everything you need to know for your course and for your exams, excluding things, of course it's got extra in there too, that we're not going to be assessing you on. Anyway, 5.2, use information from figure 8 above to calculate the current through component Y when the potential difference is 0.7 volts. Okay, give your answer in amps. So current when the potential difference is 0.7 volts. Well, we have a graph of milliamps versus potential difference, where it's find 0.7 volts. It's here, and I'm going to sketch up. On paper, you can be a lot more accurate, but it goes to, I'd say, here. Tracing back. So at 0.7 volts, the current is 16 milliamps, but we want our answer in amps. Well, if I wanted to convert from millimeters to meters, so this is 16 milliamps, then I'd have to divide by 1,000, and I'm going to do exactly the same to go from milliamps to amps. So 16 divided by 1,000 equals 0.0016 times 10 times 100 times 1,000. No, it is going to be 0.016. Apologies. Yeah, that's correct. 0.016 amps. So take away from that question there, don't be scared of milliamps, don't be scared of kilometers. If you're really struggling with them, think kilometers to meters. Think millimeters to meters. How do you convert between millimeters and meters? It's the same for milliamps and amps. How do you convert between meters and kilometers? It's going to be the same for amps and kiloamps. Calculate the resistance R of component Y when the potential difference V is 0.7 volts. So I'm very fond of making note of what the question tells me. V is 0.7 volts. We're looking for R. Do I know any equations that link V and R? Yeah, I do. I know one with current inside it as well, and that's I. We just worked that out. 0.016 amps in the previous question. What was the equation? Well, another one you need to remember. V equals IR, or potential difference, equals current times resistance. Of course, you will need to rearrange that for resistance R. I could divide by I on both sides, and I'm left with R equals B divided by I. If you're still looking using the triangle, your triangle will look like this. And you will be able to conclude by covering up R that R is V divided by I as well. Anyway, let's put some numbers in. Potential difference, 0.7 volts. Just to clarify again, when I'm saying I, that's what we use for current. So the current we worked out in the last question to be 0.016 amps. When you put that into a calculator, you are going to get an answer out of 43.75 ohms. But one last step. This is why this relatively simple calculation is 3 marks. Give your answer to 3 significant figures. Significant figure 1, significant figure 2, significant figure 3. So I need to round it to 1 decimal place. 43.8 ohms. 5 or above, you go up. Good, that's question 5 completed.